Hello, everyone. This is Agential Topics, and I'm Charlie Munford. Agential Topics is a private meeting put on by Agential Biology Institute, or ABI for short. ABI is founded because we think that there's a missing causal layer in biology that gives cells an intentional directionality as they develop, and we're building the infrastructure to study that missing causal layer. And this meeting is a periodic group where we discuss the questions and proposals for what that missing causal layer might contain or be or consist in. And without too much further ado, our new guest today is Alicia Guerrero and or Guerrero. I'm not sure if I pronounced it correctly,
It's hard
but
for Latin Americans too, so don't worry.
okay, well, yeah. Great. Anyway, thank you so much for being here, Alicia. And I'll allow screen sharing, hopefully, if you have any slides, but if not, we'll just
Yes,
go
I
right
will
ahead.
do that. Okay. Let me see, share the screen. Okay, which do I want to do? This one. Okay.
Great, I'm seeing it.
Can you see it?
I can see it. Yeah, it looks like it's showing your whole screen.
Okay, let me share the other.
Maybe you can do it as
Yeah.
just hit slideshow, maybe.
No, I did. It's just that I have two screens, and so that's what.
Sure. Okay.
Okay. Uh, Better?
It's showing your desktop now. It's showing all your
Okay,
files.
so that's exactly what it's not supposed to do. Wait a minute.
Sorry.
Um,
Yeah.
okay. Now?
Yeah, perfect.
Okay. All right.
Great.
Okay.
Awesome.
Very good. All right. So thank you so much for inviting me. And I said to Charlie, you sure you want me? I'm not a biologist. I'm not a cognitive scientist. I'm not a neurologist. I'm certainly not an AI developer. He said, yeah. Just do the philosophy part. And it's interesting because the very name of your group, Agential Topics, it seems as though agency is having a moment. It's everywhere nowadays when it used to be in the doghouse for so many times, for so long. And I have been interested in the notion of agent causation since I did my dissertation. And the first sentence in the book I published in 1999 was, what is the difference between a wink and a blink? Obviously, the assumption of being that an agent winks and a blink happens to the person. So the whole notion of agent causation is, oh, wait a minute. It's not, I'm not getting the movement of the slides. I don't know why.
Not advancing.
It's not advancing, right?
Mm.
All right, let's see. Let's do this. Okay. So what is the difference between a wink and a blink is a question, not in that terminology, but flippant, goes back a very long way. The grammar, as I just suggested, incorporates that notion in the passive and active voice mood. The and we have the word agent, but we don't much have the word patient. But in a sense, is the opposite of agency is that which suffers or undergoes an effect initiated by someone else. And philosophers like to call that mere behavior. And it has all sorts of legal and moral implications because the assumption is that you cannot be held morally responsible or legally liable for that which is not your action. In fact, the distinction between first, second, third degree murder, accidental homicide turns precisely around, well, did the agent do it or did it just happen to them? And so the standard answer is that the difference is that must be found in the cause of the behavior. So agent as cause, which fits in very nicely with your theme, is what's important. It's also interesting from a philosophical point of view that John Searle, towards the end of the 20th century, spoke about the relation. There's sort of an analogy between intention and perception. The direction of fit of causality is in different directions in each case. In an intention, the cause tries to make the world, through my behavior, fit my intention. So it has a content to it. I intend to do something, and the direction of fit is whether the outcome fits the, if you will, semantic content of the intention. Whereas in perception, it's the reverse. It is that I try to make my mental state correspond to, or that is fit, what is out there in the world. So this notion of intentionality, I don't mean by that, intention and intentionality are related, obviously, but they're a bit different. In philosophy, Brentano last century claimed that the mark of the mental is that it has a content to it. So I intend to do something. I believe that something is the case. I hope that. So most mental events, probably he should have said cognitive, but mental events have a content to it. And of course, as you guys, as biologists and in cognitive science know, that raises all sorts of questions of the representation problem. How in fact that content is represented by the subject is a whole big problem. But the point I'm trying to make is that, there is an aboutness to the intention that the agent forms to do something, right? But towards the end of the 20th century, there was also a philosopher who taught at Brown, Roderick Chisholm, and he spoke about mental processes also have a feature. They are intentional with an S. What does that mean? If I intend to kill Mary's husband, that doesn't necessarily mean that I intend to kill the chairman of the department at this university, even though John and the chairman of that department is the same person. So I present my intention, my thought, under a particular description. So Gertrude Amsterdam, so intentions cause action, but they are behavior performed under a description. In other words, it is the content of that intention that is particularly important. So in a sense, we're talking about the problem of self-motion. How does a subject initiate behavior such that it is somehow, in some folk psychology, folk philosophy concept, considered their action, and it's not something that happened to them? Unless you're able, through meditation, to control your heart rate, in general, your heart rate is something the body does, but it's not your action. So this discussion goes incredibly far back. It goes at least as far back as Aristotle in the Nicomachean Ethics. And notice that he gives this particular example in an ethics tome or essay. So he sees that there are moral and ethical implications involved in the question. And his example is, suppose you're on a small boat and you're carrying cargo, and a storm comes up at sea, and you know enough about maritime conditions and so on that you know that unless you throw the cargo overboard, you're probably going to founder, and the cargo will be lost altogether. So you should lighten the boat in order to maybe save some of the. So So the person throws the cargo overboard. Is this behavior voluntary, involuntary? And Aristotle asks, well, he adds a third category, mixed. But before I get there, the point is that the conclusion about whether it's voluntary or involuntary has to do whether the moving principle, he does not use the word intention, so he mostly uses the word volition to mean volo, I wish to, but with a motivating component to it. The moving principle, the arche, is within, and then that constitutes self-motion. That would constitute action in that sense, right? So here's the problem. Oh, and we would call coerced behavior, what he calls, in a sense, coerced behavior, is more like, contrast this example with, suppose that I am walking about the ship and I'm this person and a wave knocks me over. I bump into some of these boxes with the cargo and I push them inadvertently, unintentionally, I push them overboard. Was that my action? No, that is purely coerced, involuntary, we would say involuntary. But he does say, the situation with the boat is in one sense voluntary. The person, using his reason, weighed the pros and the cons, and on his own, on the basis of those reasons. And in the last part of the 20th century, there were reams of books written about our reasons, causes, and how can reasons be causes of action, on and on and on. But he says it is voluntary. He says, he doesn't use the word zoom out, but he's saying, if you look at the larger context, the context has placed this person in a condition where he has to do something that he really doesn't want to do, and he would not have done without those conditions. That raises the question of the counterfactual notion of causality that I may or may not get to here today. But in any case, the question does arise, well, if what makes action voluntary, which means the moving principle is inside, then how inside is fully voluntary behavior when clearly he admits you have to take the conditions of there's a storm. Without that storm, the captain would not have done that sort of thing, and so on and so forth. So he does seem to allow that external context, and its context to mean not just a Newtonian featureless container where you're plunked and not that, but context in the sense of an biological niche, an action niche, if you want to say it that way. So how inside, to what degree must it be? He does not address these questions. All right, we'll get back to this. But in addition to that example, in the physics primarily, he talks about 4 types of causes, and these are the 4 Aristotelian causes. I'll go through this very quickly. I can explain in more detail. I assume most of you are familiar with this. And I think he borrows this from the notion of a potter's wheel. So I think technology has been informing metaphysics for a long time. And he says, suppose you're a potter and you are making a pitcher. And so you have the material cause, which is the clay. You have the efficient form, which is actual energy that the arm and hand of the potter applies to the clay. But then you also have to take into account the final cause, the purpose, the telos of a pitcher, meaning what? What you're trying to make is a pitcher because it will help you achieve a goal, which is pouring liquids out. And then what makes it a pitcher? This one's the hardest one to understand, and that this goes back to Plato, even though Aristotle disagreed with Plato. there's a formal cause. What is the, if you will, essence of picturedom? And people tend to assume that form means shape. No, for the ancient Greeks, form does not reduce to shape, because justice has an essence for them, or beauty, or goodness, or truth, and clearly none of those have a shape. But for the moment, let's assume that form is the shape that makes something a picture, right? So in that sense, but what's curious is that for Aristotle, all four of these combine in the making of the picture. So what's the problem is? They operate simultaneously. Well, it's got an advantage. Looking at causality of action has that advantage, in that it can explain sustaining or ongoing causation of behavior. If I intend to write a book, not just say I intend to raise my arm, which can be explained probably just with an efficient cause, the arm going up. If I intend to write a book, there's a sustaining, ongoing causal something. And people have said it is a subtending, a supporting, a sustaining form of causation that we will see later on. If you eliminate final and formal causes, you have no way to explain sustaining causation. But let's stay to what it can work. Wait a minute. It can explain the natural motion of living things, because for example, how does an acorn, what are the causes that turn an acorn into an oak tree? And he's got the four things: the material, the efficient would be the water and sunlight and so on. But then the final cause, in a sense, is already built into the acorn. That finality is already built in. And the formal is it's going to turn into an oak and not a crocodile, right? So in a sense, an organism for Aristotle is a substance, which is a holistic integration of form and matter, informed by formal cause, that acts in very typical ways. So you'd say that's a typical behavior of that species, because final cause draws it to that completion, if you will, as an oak rather than something else. So he incorporates final and formal causes into a substance. And what I want to say is, what he's done is he's basically built in meaning and purpose into how living things change and become. Remember, motion is, for Aristotle, motion is local motion, change of location. So the essence of motion, in a sense, is just the notion of change. How does that happen, right? If you will, this built-in telos and form is what undergirds the notion of natural kinds in all classical biology, all right? But now let me give you an example of how this works, not in a potter's wheel where clearly it's the potter that's setting it up, but how would this work in a natural organism? I gave you the acorn. Let's look at a gazelle and a lion. A lion perceives a gazelle. The gazelle out there elicits desire, which is a mental property in a gazelle, in the lion, and that triggers the efficient causes of the muscles and sinews of the lion to to become active, it motivates the lion. And notice I'm using the word motivate in the sense of it causes movement in the lion, such that the lion pursues the gazelle in a particular direction in order to do what? Feed, prey on it, kill it, and feed on it. So the gazelle's presence acts as a final cause, a goal that elicits something internal to the lion. And how does this work? For the notion that this is a natural motion in animals? Well, because again, it is built into the nature of the substance lion, the substance gazelle, and that's the way self-motion occurs in nature. There's a wonderful book, if you're interested, by Gill and Lennox, and it's called something like Self-Motion from Aristotle to Newton. And I tend to agree with, it's an anthology, as I recall, with all the articles in that work that they say that, in fact, Aristotle didn't really explain how final and formal get integrated into material and efficient, right? And in a sense, please notice there is a splitting of the lion into two parts, its desire and its bodily motion. In a sense, you've got an incipient dualism there. And even though the gazelle seems to be incidental, it isn't at all. It is the source of the purposiveness of the behavior. It is what elicits the lion to become active in behavior. So this notion of natural motion in Aristotle builds in the teleology and the meaning. In addition to that, you can think of causality for Aristotle in general as being the transference from something that is already active onto something that is merely potentially active and turns that which has only the potential to move but is not yet in motion to actually move. But here's the kicker that is going to cause all sorts of problems in the end. Since nothing can be both potential and actual at the same time and the same place, for Aristotle, the motivator and the motivated, the agent and the patient, in this case, the desire of the lion and the behavior, must be separate and distinct. And it only goes one way. So even in Aristotle, there are no looping causes. You know, the activation of the lion's desire does not change the gazelle so that you get a back and forth two-way traffic in causality. This one-way influence is going to cause all sorts of havoc in philosophy. All right, so I think, spoiler alert, that the outcome in philosophy and for you guys in biology and neuroscience in particular is that if you don't allow one-way influence, you don't allow looping causes, if the agent and the patient must be separate, and you get that, as I said, you don't have to have dualism in a Cartesian sense. You can have dualism in the Aristotelian sense. The desire in the lion must be one aspect of the lion, and it motivates another aspect of the lion, the motor condition aspects, right? Okay, so how does this work in the physics? Well, if you believe that there's no infinite regress and you believe there's no self-cause, then in the cosmos, Aristotle is the first to postulate what he calls a prime mover. He doesn't call it God. But see, folks, I'm not interested in the theology here. I'm interested in the notion of, for Aristotle, causes have to stop at some point. If nothing can cause itself because you don't get looping self causes in that sense, kind of like Douglas Hofstadter's strange loops. He has to postulate a prime mover, namely, he has to postulate an extranatural, pure actuality that creates and kickstarts any subsequent actuality that then kind of like series of dominoes, potential motion of one domino changes the other one into actuality, which changes. And so, in a sense, to use Stuart Hoffman's terminology, for Aristotle, the prime mover prestates all the conditions of possibility for all future change by informing matter with form and finality from the very beginning. That's going to be an obstacle. It's going to take 2,500 years for philosophy to even think about, because I think this becomes what philosophers like to call a background that goes without saying. It's so much in the background, you don't even realize. You assume no infinite regress. And furthermore, you assume no cell cause, so the combination is deadly. So efficient causality is always one way from actuality to potentiality, no strange loops. So that means, in today's terminology, no recursion, no iteration, no feedback. And I hope I'll get to where Kant tries to pull it off to try to see how he can change this. And he comes to the conclusion, no, this requires a form of causality unknown to us. And that's the end of that. In other words, mereology gets effectively banned from philosophy, and I would suspect until hierarchy theory gets resuscitated at sort of the last 25, 30 years of the 20th century, it gets effectively banned from philosophy. What does the word mereology mean? Mereology means the relation with parts, between parts and wholes. So the idea that maybe separate and independent entities can, through constrained interactions, generate a whole, W-H-O-L-E, that has emergent properties that the individual components do not have. Simply, that concept is banned from philosophy from the get-go. The term mereology almost is, you might never have heard the word mereology because it was banned from metaphysics. It was banned from philosophy. So therefore, you don't have the possibility of having sustaining causes, because the idea would be this whole maybe spans a longer period of time. It has more moving parts. It is larger. And it is what holds together the erstwhile component parts, the erstwhile elements that are now components. See, nothing can be a component until you've got a whole of which the thing is a component. You cannot have a functionality without this overarching constraint dynamic in terms of which the thing is a function. It is a function in virtue of the role it plays in the service of this overall whole. So this is why I've spent so much time taking a look at this, because this is the background that goes without saying that I think biology and neurology have been working on. So in a sense, agent causation implicates three important problems in Western philosophy. What maybe today is called the binding problem. How do you bind together formal and final causes which give meaning and purpose? That's in today's terminology, mental. See, Aristotle didn't have that problem, because for the Greeks, there were three kinds of minds. There was the appetitive mind, which is plants. There is the vegetative mind, which is plants, the appetitive mind, which are animals, and then human beings have the ratiocinative or rational mind. So when he builds in formal and final cause, he does that for each of the different kingdoms, if you will. And so he's got it all solved. But today we've got a problem with how do you explain a wetware neural or biological, but it's the same problem with an ecosystem. how do all these diverse species of plants, animals, and so on bind together to form, integrate, if it's a better word than bind, to form an ecosystem that has emergent properties on its own that the components by themselves or separately don't have. So it's not a summing problem. It's not that you can say the emergent properties are the sum of, and therefore I can reduce them too easily by decomposing them. Oh, they're partially discomposable, but not completely, as Simon would have said. So the whole notion of mereology, and I will make a big deal about temporality of coherent wholes. So I want to say this includes lineages, because clearly, as I implied, the acorn doesn't turn into a crocodile. So you have a lineage that acts as a constraint, and I'm jumping the gun here, on the behavior of the component parts, how much they can deviate from the variability allowed by the coherent hold or not, and that sort of thing. So here I was trying to write a dissertation at the last quarter of the 20th century, trying to explain the difference between morally justifying behavior and explaining behavior. Well, you explain behavior by giving its cause, but you morally justify it by all sorts of other ways, giving moral reasons, and that kind of tied the two together well, but aren't reasons called all of that stuff. But I almost titled this slide, Meanwhile Back at the Ranch, meaning meanwhile, outside of academic philosophy, I was lucky that I had a lot of friends who were in operations research and systems dynamics, and they talked a lot back then about network theory. I'm not talking Laszlo Barabazi network theory today. I'm talking network theory of control systems way back then. And they would talk about, well, how can this network all of a sudden do this at the individual? In other words, they were talking about network properties. And so I kept thinking, this has to be what's going on in the human brain. This is the sort of thing that's happening. But there was nowhere that I could find inside of philosophy that would give me any of this, because all of this was sort of verboten in philosophy. So I found hierarchy theory. And hierarchy theory was wonderful because I was looking at hierarchy theory from the perspective of biology, and I'm thinking of the works back then of people of Howard Patty, obviously, the early. I've got one slide later on that has the whole bibliography, and I organized it by date so you can see how it sort of developed that way. Hierarchies in biology that then become ecosystems. The hierarchies become more stable and evolve faster because they are organized as hierarchies. See, and this is important because against this background, you had the problem with the second law. So how do you explain organization? How do you, could you reduce formal cause to organize? Well, but you have to do it in a way that it's not external to it, must satisfy the second law. And so parallel to the notion of hierarchies, in the mid-1970s, bit later, it developed later, Ilya Prigogine gets the Nobel in 1977. So the whole notion of dissipative structures and far from equilibrium thermodynamics was able to give an account whereby organization, satisfies the second law, indeed promotes the second law, because the structures they generate, the hierarchical organization they generate, are metastable despite remaining far from equilibrium. And I'm not talking just chaos theory, but of course, chaos theory provided a big impetus to this, because if Aristotle is the background in philosophy, Aristotle the notion of efficient cause gets consolidated with Newtonian laws of motion, where forceful impacts replace the more generic notion of efficient cause, and that's the only way you're able to explain anything according to this model. And I had about 4 slides in between these two, but I didn't want to include it. I'll just mention in passing, positivism at the beginning of the 20th century consolidated the notion of linear, deterministic, efficient causes as the only source of causality. And therefore, there was nothing to be done at that point. And so I kind of grew up in philosophy and in analytic philosophy. You know, in retrospect, you think back and going, all those decades were just kind of epicyclic contortions of philosophers trying to shoehorn all these problems that are showing up in mental states and so on into a Newtonian efficient cause model. And it's not, biologists were the first to recognize it ain't gonna work. But then, of course, C.P. Snow says, oh, well, you know, you've got science and then you've got philosophy. But Peter Allen worked with Prigogine and did wonderful work in complex adaptive systems. And so here I was trying to work this out. I already submitted my dissertation, which I've never looked at since because I thought it was awful. And I happened to be reading Kant's Critique of Practical Reason. He's got a section called the Critique of Teleological Judgment, where he's trying to explain the natural teleology, purposiveness of plants and animals. And he gives an example that just, to me, was amazing. And then he said, think of a tree. A tree produces the leaves, but as produced by the leaves. And that's the way the directionality of the organism occurs, you know? Not have to appeal to a prime mover, you appeal to that. But then he says, however, this is a form of causality unknown to us, which I mentioned earlier. This looping back and forth of the leaves produce the tree, but the tree is the source of the leaves. This back and forth is a form of causality unknown to us. And while I'm reading this, I happened also to be reading it at the time when Ilya Prigogine and Isabel Stenger's book, Order Out of Chaos, appeared. It was about 1984, 83. And what the Bernard cell of dissipative structures that Prigogine gets the Nobel Prize in chemistry for. I happened to have met him once, and you could tell he was sort of upset he didn't get the Nobel in physics, that he got it in chemistry. It was kind of interesting. There was a resentment there, but it was interesting. But the question about how under far from equilibrium conditions, right there you've got a difference from the second law, where all the second law presupposes closed conditions near equilibrium. So all the examples in the second law are, a bunch of molecules of gas in a container that's closed, and what happens, even if you put a partition between the two and you remove the partition, it's going to, no, the boundary condition there is a closed boundary condition of pre-stated possibility conditions, which Kaufman's always harping against. But in dissipative structures, you have open, far from equilibrium conditions, which means you get energy inputs and you get, what's the word I'm looking for? Exchanges of matter and energy and information. And at a particular threshold of instability, what happens is that all of a sudden you get a phase change where independent individual molecules of water create a Bernard cell, which is basically when you're boiling water, these rolling hexagonal forms of motion in a pan. Now, what I found fascinating is that once the individual molecule is entrained into this hexagonal attractor, the attractor as a whole is capable of controlling, it exerts top-down control on the individual molecules. So the molecules have a limited range of motion. To me, that's a form of top-down causality without having to talk about formal and final cause. And so I put it together in a little paper that the Review of Metaphysics published in 1985, and it was on Kant and Ilya Prigoghine's notion of dissipative structures as to how this notion of teleology and indirectly formal cause could now be accounted for by chemistry. And so here's where I stopped reading philosophers and I started only reading these folks. So if you look, I confess I did not read Simon and Gatlin until much later, but they were way early. And he's got the parable of the two watchmakers, where if you create a module and you save the module, you can build the whole thing if you get interrupted much faster. So in a sense, it's an old example of stable modularity, which then dissipative structures kind of take one step further. Information in the living system, you'll see I borrow the notion of context independent and context dependent from Lila Gatlin. And here are the Howard Paty with hierarchy theory, Stan Salty with evolving hierarchical systems, Allen and Tim Allen and Tom Starr, hierarchy perspectives for ecological complexity. Of course, here's where I came into the picture by reading Order Out of Chaos here, that led me back. And if you want to understand complexity theory, the second chapter of Eric Jansch's Self-Organizing Universe is fabulous. The anthology that Johnson Seleni, and in these anthologies, Paty has something to say, Levin has some, the Levins, the old Levins, not Michael Evans, the Richard Levins. And so I strongly recommend. Our favorite and Shaw did a graphic book, comic book, on the dynamics of complex systems. And Robert Rosen starts speaking of anticipatory systems in evolution and extinction cascades. And so all of a sudden, 1985, the notion of anticipating an endpoint is starting to get scientifically respectable accounts, so you don't have to appeal to teleology. I strongly suggest Dan Brooks and Brooks and Wiley, Evolution as Entropy, because they, and Dan is now a good friend, they take evolutionary theory and look at it from the view of these entropic, the Bernard cell, once it's self-organized, has lower rates of internal entropy production. So it gets formed with a burst of energy that increases entropy overall, but once organized, it shows lower rates of internal entropy production. So I would say if I were a biologist and I were a neurologist, I'd be looking for dynamics that show lower entropy rates of entropy production locally. And you wonder if that's the overarching dynamic that then now has the individual. So the rolling Bernard cell, the BZ reaction with those moving waveforms or spirals, all of that. Depew and Weber talked about Darwinism evolving. So again, you start getting the notion of evolution, and so I can do this later. So this led me, because Lila Gatlin speaks of context-dependent and context-independent constraints, to, all right, so how am I going to explain this form of causality? And I decided early on there was no way that I could ever fight the word cause and the concept of cause. That had been, and that was entrenched with the notion of efficient causes, and ain't no way I was going to win that one. at all. So as I looked at Lila Gatlin, she speaks of, or I thought, well, what about the notion of constraint? The notion of constraint seems not to have that negative baggage. It does have one baggage that I'll mention in a minute, which is that it, in popular language, it tends to mean limiting. But so apparently the 14th century notion of constraint is not just compulsion, it's also of a binding, but that kind of gets lost. So I think in terms of the way causality is, constraint is used in mechanical engineering, is that it limits or restricts degrees of freedom. So you get bottlenecks as a result of these constraints sometimes. And so, but then I discovered that Patty, Selty, and Allen are perfectly happy using the notion of enabling constraints. And these are constraints that do not restrict degrees of freedom, but on the contrary, these are couplings that expand and increase the degrees of freedom. Thought, all right, I'm going to go with the notion of constraint. And so I took Gatlin's notion of context dependent, combined it with Maturana and Varela's notion of organization of dissipated structures. And then what finally convinced me to publish the first book was Hinton, Plout, and Chalice's oh my goodness, we're talking the early 1990s, where Gerald Hinton, and they publish as Hinton and Plout, Plout and Chalice, Chalice and Hinton. So I think of them as the three folks working early on silicon neural networks, where they train them with feedback loops, sort of early backprop, like feedback, circular causation, so much for Aristotle. And if you lesion these neural networks below the feedback loops, they commit the errors of deep dyslexia. In deep dyslexia, the semantic meaning of the middle weights is preserved. Anyway, this does it. This explains what's going on. That self-organization, whether it's Bernard cells, Bezier reactions, ecosystems, biology, all of this, they're creating attractors that have emergent properties. And at each phase change, at each major transition in biology that Sazmari would propose, you get an emergent property that's characteristic of that phenomenon. So I put together the idea of two types of constraints. In the first book, I called them context-free, and somebody said, don't ever call it context-free, they're never context-free. Okay, so context-independent. And these take a system away from equiprobability. So context-independent constraints established inhomogeneities, so energy can flow. So I'm thinking inflation in the cosmic scale, from a white noise kind of plasma gradient, you get this cosmic inflation, which sets up a gradient, but you also have context-independent constraints in the form of polarity, charge, chirality, the handedness of subatomic particles, gravity itself is a form of gradient, density. And so, but context-independent constraints by themselves aren't going to solve my problem of complexification, where you have a hierarchical organization where the overarching dynamic controls the components. So, and the question here is the following. If context-independent constraints were all that mattered, in the early universe, everything would have either dissipated away into nothingness or white heat or heat death with centripetally, or conversely, it would have contracted back into a massive black hole and it would have imploded. In that sense, nothing complex would have gotten going. So what I speculate is that if context-dependent constraints take a condition away from independence, at some point, maybe at some level of density in the early universe, this new type of constraint, context-dependent constraints, kicked in. What I mean when I say that they take conditions away from independence, and these are Gatlin's terminology, they couple isolated entities. So examples of context-dependent constraints would be shape, as in lock and key, or ball and socket, or bonds, like molecular bonds. But also they are looping constraints that tie together, that bind together, that couple. In feedback, for example, I think of when I do something and then I get feedback. In a sense, I am exporting my part of me into the environment, which in return gets imported by me changing both, right? So feedback, recursion, iteration, and of course, catalysis, and especially autocatalysis that combines the loopiness with the lack of transfer of energy involved. But you also have temporal context-dependent constraints, and that is timing. My favorite example is a child on a playground swing at the beginning thinks that she or he has to kick harder. It takes a while for them to realize, no, it's not the hardness of the kick, the strength of the kick. It is the timing of when you kick. And yet the timing itself does not impart additional energy. And context-dependent constraints, I think, create ordinality, where first must happen, second, a recipe is not a disordered temporally arrangement. First thing, you have to do something first, then second, then third, and so on. And that makes a huge difference for producing a result that is different from what you had individually. I understand, I am not a quantum physicist, that Heisenberg's matrix does imply ordinality. In other words, the order in which these matrix operations are done makes a huge difference in the quantum realm. And well, people couldn't believe that was possible. Certainly we understand the importance of phases. Now people are talking about applying chemotherapy or some kind of treatment at a particular phase in the tumor's development, because then that intervention, depending on the phase, can make a big difference. So that is what led to my book in 1999. What I was trying to do was take Kant's notion of the tree and the prigogine as to how things self-organize, to provide a scientifically respectable notion of mereology, where mental processes must be some kind of neuronal self-organized attractors that lower local internal entropy production a la dissipative structures. And so what happens when these attractors can show emergent dynamics, namely semantic properties, and that's the Hinton-Plaut-Challis. I figured if it happens in silico, I bet something like this is happening neurologically. And so when Hinton, Plaut, and Challis were asked, well, how is it possible that if you lesion a neural network below the semantic attractors and you show this silicon neural network the input BED, the output might be COT. In other words, COT doesn't look at all like BED, and these were neural networks designed to learn or trained to learn to read words. So you show them BED and it says it read COT, or you show it BAND and it says it read orchestra. How is that possible? And their answer, I think it was Plaut or Challis, who answered, well, the only explanation is they must have self-organized a semantic attractor, an attractor with the emergent property of meaning. So you don't need it to be imposed from without by a prime mover. So actions are behavior that originate and maintained within a semantic attractor. So to repeat, they take conditions away from equiprobability, they create inhomogeneities. When I read Conrad Waddington's Epigenetic Landscape, the original setting, the original few little indentations on that setting, to me, are the result of context-independent constraints that might be because of cosmic conditions, geological conditions, and so on. They create inhomogeneity so energies can flow. Context-dependent constraints take conditions away from independent, and they produce couplings and dependence and mutual dependence, mutualisms between previously independent. It's why have we just discovered fungi? I never know how to pronounce it. Why hadn't people realized this before? Well, I think for the very same reason that Lynn Margolis's notion of symbiogenesis was poo-pooed and dismissed early on. It might have been because she was a woman, but I think it was also because this notion of mutual dependence and circular relationships was not part of the philosophical conceptual framework. And so, in a sense, context-dependent constraints are what you need as enabling constraints that enable coherence formation. So you have a way of bringing coherent dynamics back, which Aristotle kind of built in a petitio principii. He cheated by speaking of organisms. Well, yeah, they already have that built in, so all they do is unfurl. Oh, one thing I did not mention that you might find interesting. Because of these ideas of Aristotle, the Pew and Weber argue, and I think they argue successfully, that in Aristotle there is no possibility of evolution. There is only development. In other words, all of Aristotle's notion of change, I should have pointed out, leads us to the conclusion that change means development. They develop towards a pre-established endpoint that has already been built in at the beginning. For evolution, we think, at least in terms of Sazmari, as major transitions where you get novel possibility landscapes, novel parameters, novel relationships, novel features and characteristics. So in Aristotle, there's no possibility of evolution, whereas I think context-dependent constraints do give you the possibility of a whole, a coherent dynamic that has properties that the components don't have. So they are self-organizing. And so they really form multi-scale heterarchies. I don't much care for the word hierarchy, although that one's the one that's best understood, because hierarchy seems to imply just almost, certainly in social science, hierarchy is the implication that it's top-down arbitrary commands and fiats from the ruler or the top, alpha male or whatever. Whereas these interlocking interdependencies, I think, are better understood as heterarchies. Influence goes horizontally, intra-level, but they also go inter-level, bottom-up, and top-down. And so I think of these interlocking interdependencies as constitutive constraint regimes. And this is what I decided I better write another book that emphasizes constitutive constraint regimes. Because what these constitutive constraint regimes do is that because they are longer lasting, because they take more time, or they are higher, their scale and depth are larger, they can persist beyond the turnover of the components, while at the same time lowering local entropy production. My personal opinion is that this is what AI is missing right now. And the fact that it lowers local entropy production, I think, is extremely important. It's not just efficiency. It is a lowered local rate of entropy production, which is, I think, why our brain uses, 25 watts, whereas the data centers that are being built require zillions of kilowatts, because it isn't, because we need coding in terms of the interlocking interdependencies, the constitutive constraints. And that's what I think the brain figured out how to do. In addition to being constitutive constraint, the constraint regime being a constitutive constraint that holds all these goings on at the local and lower levels together, that constitutive constraint regime also acts as a governing or stabilizing set of constraints top down. What it does is it adjusts and selects among pathways or configurations depending on their overall contribution to the metastability of the whole. And I would again remind myself of the importance of temporal constraints. So the constraints we bring with us through inheritance and reproduction show that these constraint regimes are path dependent. They're not Markovian, which again, Newtonian force regimes are. So they are path dependent. And so Prigogine, I heard him speak several times in person, and he always liked the phrase, they carry their history on their back. So dissipative structures like snowflakes, the shape, the specific shape of each snowflake embodies the trajectory, the journey that it underwent before it crystallized. So how, this is, I think, almost my last one. How do you explain what Aristotle didn't pull off? I think that against the background of context-independent constraints, yeah, I said gravity is one of those. You know, you can really afford to take them for granted because they really don't vary much. Except now, look at the problem with astronauts. We're having to figure out, well, this lack of gravity is wreaking havoc on a lot of their biological processes. So they ain't that context independent when you're traveling in space, correct? But let's assume against the background of more or less given back stable context independent constraints, then enabling context dependent constraints can generate these interlocking interdependencies. So they are facilitated. You know, people say, oh, that's enabling to me. No. Enabling doesn't mean it lets you do whatever you want to do. It means that it enables the generation of a system-wide or system dynamics that shows lower rate of local entropy production, which constraint regime, this overarching set, and I would say, obviously, the paradigmatic example is homeostasis. Homeostasis is not another organ. It's not another organelle. It is an overarching set of interlocking dynamics and constraints that is constitutive of the range of viability within which this system ought to stay if it is to be viable and thrive. This is what I think Paty was looking for when he talks about, oh, these hierarchies have semantic closure. They might be operationally open, but they're semantically closed because they remain metastable, because that range of variability gives you a normative metric. Lo and behold, you get norms. Now, I grant you it's not human morals, but in a sense you have, this is a better diet than this one because it promotes this range of or furthers or supports this range of viability. And so you also have the possibility that this is a sustaining cause. And it does so by a controlled dynamic where they self-repair, moderate, modify, and promote. How? So if you don't want the phrase top-down causation, which people will, it will trigger an awful lot of people. No, you don't have top-down causation in nature. Well, yes, you do, but except you guys call it regulatory and modulating instead of causation, in order for the system overall to remain within the range of viability. And I want to, so this is the book. Before I say that, I always would joke with Stan Salty, who died last year. that the reason why hurricanes are given proper names is because they all exhibit these characteristics. There is a vectorial component to a hurricane. They will go towards areas that are warmer and a certain pressure dynamic. And they are path dependent of what they happen to have encountered that time and the history. And so, in a sense, each one is pretty much unique. You will, even though our predictions have gotten better, you will all of a sudden have one that will change it. Oh, wow, we've never seen one have done this before. Kind of like people. So I joke, and so this is what I tried to say in the context changes everything, and that is, I think this idea scales from the abiotic through social systems. It's through constraint, enabling constraints, formation of constraint regimes, and then the governing constraints that you have a whole new possibility landscape of meaning, and it underlies self-maintenance. Proust and Pascal talk a lot about chemical persistence, but I think, well, but how does that happen? I think it happens in terms of constraints. And it is multiple realizability. And here's where I am in purely speculative mode at this point. I think that when you get that closure of a constraint regime, you get a transition from digital to analog. So I would suspect if each neuron spiking can be thought of as a digital process, on, off, then once you have neuronal phase sequences, that has become an analog phenomenon that can support emergent properties that the individual neurons cannot. And so then the question is, how do we deal with this? Well, what we have to do is look for what is the degree of flexibility of this constraint regime? Are they easily modifiable? Are they easily evolvable? Well, obviously, constraints early on in embryogenesis in pregnancy are much stricter, because if you get the bowel plan of the body of the animal screwed up, that's going to pretty much kill it. So they are stricter constraint regimes, whereas later on they allow variations. So how does that happen? What is the timing process of each constraint regime typical of each species, or how much leeway does it allow each individual within the species? So that's, Charlie, I think I just about did it. 9, 12, 10. I said I probably take an hour, but I think that's about it.
Thank you. That was wonderful, Alicia. Thank you so much. Totally fascinating. So, what we'll do now, we'll have a discussion.
Great.
So guys, when we go into the discussion, if you look down on the bottom of your screen, it says react and then raise hand. You click react and then raise hand, and that'll put you in the queue. And I'll just call on people as their hands go up. I have one question to start off with, and great, you guys are doing it right. Thank you. Let me end the screen share right quick. Maybe you have to.
Oh, me, I have to stop
I
sharing.
think you might have.
Yeah.
Thank you.
No, yeah. Let me stop sharing.
Um,
Okay.
yeah, that's great.
All right.
Thank you.
Okay.
Yeah, so my question, just to kind of get into this with a little bit more specificity, is about so the problems we're concerned with in this group, they have to do with the genome under determining the phenotype.
Right.
And they have to do with, Lamarckian inheritance and the sources of variation. So, when we've talked to people, and most of the ideas that have been proposed, um, most people that are kind of, at some level of sophistication and they're thinking about biology already recognize that there are these emergent, order producing spontaneous processes in biology that sort of give coherence to to organisms. And I think your rubric of context independent versus context dependent processes is really useful. and I think some of the things people point to are are independent and some of them are dependent. So like, people talk about like gravity or friction or adhesion, cohesion, surface tension, resonance, like those sorts of things. And I can think of some of those like gravity is kind of totally independent, right? And, some of them like surface tension might be context dependent. But my question is, you know, it's not so much the presence of those processes that I find um, relevant, because what we're trying to explain is the sources of variation. So like whatever processes that are spontaneously present, they're already present before the next generation varies. You follow me? So like we're what we're looking for is what explains the delta in those
Yeah, yeah, yeah,
processes. What explains why those processes vary together in a
right,
congruent way so that the organism resists some stress that it's never encountered in its evolutionary history, like Mike Levin's experiment with the barium melting the heads of the planaria, and they regenerate barium resistant heads. So
correct,
the surface tension and the gravity and all that stuff is already there,
right.
but there's been a change to whatever those processes are that produces this new resilience. And so, um, yeah. So how do the constraints co-vary together in biology?
Yeah, well, that's
Kind
the
of
question. That's
question.
absolutely that's the question. And but I think that's where you have to look for it. That's where you have to look for the problem. In other words, um, what capability did the previous constraint regime have to be killed by the barium, but at the same time become barium resistance in the next? Correct. That's what you're saying. And what my answer is, you're not going to find it in either or. You're going to have to find it in the overarching dynamic of the capacity of the interface to handle barium,
Mhm.
right? And how that um, there is an example in the book that Dan Brooks gave me, and it's a species that only fed on plants, but then when some organism ate it, it became adapted to that organism to the point where then the organism was able to eat the other thing as well. And so
Mhm.
the question must be something about there must be overlapping dynamics with the adjacent possible. I mean, that's a question I've always had for Stu, and that is, so how do you get that adjacent possible as adjacent, right? And so the answer would be, well, if you think of it in terms of a Venn diagram, well, you might understand that this side, which was vulnerable to the barium, died off, but then this side that somehow had additional capabilities gets highlighted in the next generation. But that must mean that in principle, constraint regimes must all be multiply realizable. So no constraint regime can be one-to-one, which is why the genome cannot be the constraint regime that one-to-one gives you the phenotype.
Mhm.
So it's genotype within a particular context. So it's the cell within the tissue,
Yeah.
right? And that's what I don't. I mean, I know I didn't answer the question because but I would. That's what I would think the answer would be coming from, in a sense.
Yeah. Totally.
Sorry, I don't know the biology.
No, that's
Uh,
okay. No,
I
no, no
don't know the
problem.
biology. Here's
No
another
problem.
example that Tim Allen uses that I really love. Tim Allen says that in the grassland ecosystem in the prairies in the north central part of the United States, the grasses all of a sudden became threatened by the introduction of forbs. meaning like hoofed horses, for example, but also they were threatened by flowering plants. Now, if you think of it from the perspective of a flower of a grass, the flowering plant is harder to fight. But what happened, and he says over time there's no such thing as an ongoing black swan. It never happens, because what happens is, look at what happened with nature. Look at what happened in the prairie grasslands millennia ago in the north central plains. And that is, they put out meristems. This sounds very anthropomorphic. I realize I don't mean to. They put out meristems that called in the horses. And so the horses became part of the overarching ecosystem there, because they'd rather have the horses. The grass would rather have the horse. Why? Because it's always looking for levels of metastability. And for them, introducing what was a predator, your boron. Your boron. Hey, Stu, how are you?
Hi, Alicia.
I'm getting into your area with adjacent possibles.
Cages, and forgive me, I'm eating a piece of toast with honey on it.
No problem. No,
Hi, Joanna. Hi, Charlie.
Hi.
Catherine, I suspected you were infiltrated.
Great.
I'm not sure what that means, Alicia.
Well, is there anything Stu might be interested in butting in on? How are you?
Am I?
Yeah.
Well, this is something, listen, I think I'm older than everybody else on the call, and I want to report that a year and a half ago, I got old. Charlie, this is really, it happened very suddenly. Kate and I were in the south of France because I was going to turn 85 in a beautiful, beautiful, hotel and I'm in a rocking chair, 2:30 in the afternoon, and I thought, I'm just like an old man enjoying sitting in the sun.
Nonsense.
And the thought came to me, Alicia, what do you mean like a? I am a. And with the AMA, I became an old man. It's great. It won't, you have to be somewhere in your mid 80s for this to happen. But it's fun.
That's great. That's awesome.
That's great.
Another thing that I could say is one of the oldest here. A sense of humor as you get old is really important.
Yeah.
So one story, when I was young, I was a mountain climber with my friend Mac McGarry. And we climbed really scary things in the Tetons and so on. Mac's a year older than me. A year ago, he and I were talking, and he says, he's very laconic, this Kaufman. When I go into the woods now with my walking poles, I have to use my walking poles when I pee so I don't fall into my pee. Now that's just funny. Anyway.
No, Stuart was one of the first people to pick up on the Kant self-organization, that paper of mine, because I really think that's important. He says it's a form of causality and known to us, this auto, and that's why your autocatalytic set. All right, here's a scientifically respectable way that Kant didn't see or didn't have at his disposal.
Well, meanwhile, Kant had it. Do you all know?
He had it. Yeah, I mentioned the story about in the Critique of Teleological Judgment. I was reading it at the same time as I was reading Order Out of Chaos. Sitting in a jury room waiting to be called. I'm reading both together at the same time. I'll never forget that. And I read that he says the tree produces the leaves and is in turn produced by the leaves, which is parts interacting to produce the whole, which in turn constrain, create the parts, create the boundary conditions that are required to create. So he doesn't use that terminology, and then he says, but we have nothing analogous. We have no that is a form of causality unknown to us. So he goes back to the Newtonian notion because he had been awakened from his dogmatic slumbers by Hume, who was enamored of Newton, and end of story. Mereology disappears from philosophy.
That's true, and it's been lost for 200 and whatever years.
Correct.
So what Kant was looking for is a natural sense of purpose.
Well, or
And
self-organization, and because
Mhm.
apparently the word self-organization in German back then Kant dies in 1804, so figure turn of the century of the 19th century, the word was self-organization for purpose.
Really?
Yeah, I don't speak German, but somebody said to me, there's an etymological reason why Kant uses that term. And so he was trying to explain purpose in terms of self-organization. And he says, I can't do it, that we have no form of causality that can accommodate it. Going, why? Where did that come from? Came from Newton, which in turn came from Aristotle's efficient cause,
Right.
which despite Aristotle having built in formal and final causes, he really doesn't, because he builds it in because God creates the whole, Aristotle, here's a line for you, Stu. Aristotle created the pre-stated space of possibilities where
Yes, he did.
everything develops, but no evolution. There is no novelty.
Right. There's no novelty.
Correct? So
Yeah.
Aristotle does not allow for evolution. That's the Pew and Weber, your friend Bruce Weber.
Yes, no, I know. Yeah, that's right. And Newton doesn't either. It's the pre-stated phase space.
Of course. And classical thermodynamics doesn't either.
Correct.
Correct.
It's a pre-stated volume of gas with fixed boundary conditions.
Correct. And so that kind of has been what I've been doing for the last 40 years. My goodness.
I know you have.
Seems that way. 20.
I think you were the first.
30. No, but it just hit me. Oh my goodness, this is what this is. And then if I'm going to use Stu's language, what language should I use? Oh, pre-stated possibility landscape or problem space or whatever you want to use. If you've got it all the possibilities and the potential with a particular directionality, not particular termination, then it's all set there for you. It's really, and if you don't have the prime mover, we got rid of formal cause and final cause, then how do you explain it? And my answer is, you guys in complexity, nonlinear dynamical systems theory is what solved that problem.
Let's see, who's it? I guess Carl, Charlie, you're in charge, right?
I mean, nominally, yes. Yeah.
Well, you're the only person on who's got a beard.
Well,
You're a male leader or something. Listen, I'd like to explain something. Professor Frischem, are you really on here?
Oh my goodness. One of my heroes, Carl Friston.
there he is.
Oh my goodness.
He's our next guest. Yeah.
I must watch it.
Yeah.
I have read Carl Friston forever.
Well, Charlie, can I try to explain something? And Professor Frischman, may I call you Carl?
Yes, of course.
Okay, so and I'm Stu. I truly love your work.
I do too.
And I want to challenge it. Okay, so I'd like to get across, I think, 3 ideas. I have for years talked about autocatalytic sets, and Joanna, who is somewhere here because she just disappeared, has done brilliant work. There's very good evidence that Joanna found that all 6,700 prokaryotes have small molecule collectively autocatalytic sets with no DNA, no RNA, no proteins in them. They haven't worked in vitro. I mean, well, they haven't worked. They haven't worked in a test tube yet, but it looks like they do. And they have, a few hundred molecules and a few hundred reactions, and they are collectively autocatalytic. So collectively autocatalytic says there's a bunch of molecules, a bunch of reactions, and the molecules in the set plus the food set catalyze the reactions in the set. So every molecule in the set has its last step catalyzed by somebody. So all the molecules collectively catalyze one another's formation. So take the idea of a collectively autocatalytic set. And for years, I've been thinking of that as a Kantian whole. So a Kantian whole has, as Kant says, the properties are the parts exist formed by means of the whole. So
Correct.
not only in Joanna's case, Gonan Ashkenazi has a 9-peptide autocatalytic set. Um, and he feeds in from the outside two half fragments of each of the peptides. And peptide 1 ligates the two halves of peptide 2. It pulls it together and ligates them to form peptide 2, so on around the cycle. And it really works. This proves that an organized structure can be a reproducing set of molecules. And it's a Kantian whole. Peptide 1 exists because it's part of the whole, but the whole exists because it's made up of all of these peptides, right? And I was happy with that for years, and I was stuck. So let me tell you the thermodynamics. I was trying to understand the work cycle many years ago, and I'm trying to remember the physicist. He wrote a book on the second law. I've forgotten his name for a second. And we asked, what is work? Well, it's not just force acting through a distance. It is, he said, the constrained release of energy into a few degrees of freedom. So I can understand that after a while. Think of the cannon and the cannonball and the powder. So the cannon is a constraint and it's a boundary condition.
Correct.
So the powder explodes and you don't get a spherical wave. You get the powder, the explosion goes down the remaining 3 degrees of freedom, the barrel of the cannon, and it does thermodynamic work on the cannonball. Okay, so I understand that. So I'll accept no constraints on the release of energy in a non-equilibrium process, no work.
Correct.
Now, Newton doesn't tell us where the boundary conditions comes from. Well, the cannon's a boundary condition. Where did the cannon come from? It took work to make the cannon. Well, now what? Okay, it really did. And so I got a little further. I realized that work can construct a boundary condition. Work made the cannon. And I was around at the Big Bang because I'm the oldest in the group. There's no cannons. And I got stuck. And in 2015, Matteo Mosio and
Yes.
Al Monteville came
Yes.
up with this exquisite idea. Alicia, this is right up your alley.
Oh, no, it's in my 2023 book and in my, yeah, absolutely.
Yeah, mine too.
That diagram of his is
Yeah,
closure
yeah.
of constraints.
Yeah, I absolutely fell in love with it, and I missed it for 15 years.
I
Their
see.
idea is a set of constraints
Correct.
that are dependent
Correct.
upon one another.
Correct.
So I kind of misunderstood them, and I made a slightly different version that I wanted to tell you. They have the general notion of constraint A depends upon constraint B. I'm going to have a more restricted notion. Constraint A depends upon constraint B. If constraint B is a boundary condition, the constraints the release of energy to construct A. So I now want to get across the idea of constraint closure. This, Alicia, I'm really in love with this.
Oh, absolutely. I
And I,
think that's critical.
well, and being 86, it's okay to fall in love. So here's the deal. I've got, I want to get some work. So I've got three non-equilibrium processes, 1, 2, and 3, but I need some constraints. So I've got three constraints, A, B, and C. So here's the idea. A constrains the release of energy in process 1, and it constructs a B. So this is of a union of a constraint and a flow process, and it makes a B. B constrains the release of energy in process 2, and it makes a C.
Let's see.
C constrains the release of energy in process 3, and it constructs an A.
Of course.
Pause and hold it.
Of
This
course.
is a set of constraints that are boundary conditions that constrain the release of energy that constructs the same boundary conditions.
Absolutely.
This is a system that literally constructs itself. So this is the idea that we haven't had, I think.
Yeah,
So now unite that with autocatalysis.
correct.
So
Okay.
Gonan Ashkenazi's set does both. So do Joanna's sets. I mean, we haven't quite talked about it, Joanna, but your small molecule autocatalytic sets are constrained release of energy.
Great.
So they are a union of catalytic and constraint closure. I think that is very nearly a definition of an agent. Not quite, but almost. And it's something entirely new. So think of Gonen's set. The peptides constrain the release of energy by binding the two half fragments, lowering the energy for the activation step because they're oriented, and work is done to construct the next peptide. I think that is, I think that really is élan vital. And
Oh, sure.
there's nothing mysterious about it.
But
We just have the concept.
That's awesome.
and that's why I didn't bring that in. But poor Bergson got the floor. Einstein wiped the floor with Bergson because poor Bergson, I think, had thought he was presenting it as an imminent property. But of course, Einstein thought, I think, he was presenting it as a force from the outside, which is,
Yeah.
of course, that's the way anybody would have thought of it, given that Newtonian
Yeah.
causes are external to their effects. So, end of story. And poor Bergson never recovered from that run-in with Einstein at the time.
No, I know.
But I think you're absolutely right but I think that Mossio and it's the three M's in the Basque country,
Yeah,
Monteville, Mossio, and Moreno.
absolutely.
And all,
We're
yeah,
all sitting in the Basque country speaking this weird language.
yeah. And my family's Basque originally. So anyway, what they think that marks the origin of life.
I do too.
I think you
Well,
can
I do.
precursors because you have closure of processes, then you have by constraints, then you have closure of constraints. So there are precursors to it. That's why I think constraint dynamics are the underlying causal processes.
Well, we agree. But can I go one step further?
Well, Stu, let me try to
I,
I'll
I just want to say something for Carl, okay?
nice.
Is that all right?
Yeah, that's fine, but let's let him respond at the next meeting if that's okay, since there's several people with their hands up.
Okay, I'll just say this kind of fast, Carl. The question is what leads to open-ended evolution in biology? So here's the set of statements. If you have a Kantian whole, you could describe the function of a part. It's that subset of causal processes that sustains the whole. So the function of your heart is to pump blood, not make heart sounds. The critical next step is the following. Any part, a real physical thing, has indefinitely many subsets of causal properties, any one of which might become a new function.
Correct.
So these are Darwinian acceptations or pre-adaptations. And that's where we get open-ended evolution. So the heart could evolve to detect earthquakes. So those are Darwinian pre-adaptations or acceptations. The point, Carl, is the following. I claim that, and please defeat me if you think I'm wrong. I don't think you can deduce the new use of something. So I can use an engine block as a paperweight, and I can use its corners to crack open coconuts. From the use of an engine block as a paperweight, I do not think you can deduce the use of the engine block to crack open coconuts. It's not algorithmic. The point is, this is really fundamental for us to puzzle about. I think that's where open-ended evolution comes from, and it bears on the work that you're doing, Carl, as I understand it. You begin with a pre-stated set of categories, and you do a Markovian blanket over them and Bayesian updating, and it's gorgeous. But there are things that arise in the world that weren't in our original set of categories, like swim bladders. So that's where novelty comes from. And I would love to hear your thoughts. You're going to be talking. You'll talk, but how do we get novelty? There's something non-algorithmic about it, and it takes us beyond what we've thought before. There, I'm done.
That's beautiful. Stu, thank you so much. But,
Thank you. Now I butt in, and it's all Kate's fault.
well, thanks. That was a beautiful question, and I hope we'll get deep into that
I
at our
am
next
looking
meeting.
forward to Carl's talk.
Yeah, definitely. Right now, let me call on Joanna, and then we got Joanna, then Richard, then Kate.
Hi, Alicia. I'm here like a child. I'm so excited. I have my brain is pumping in every possible direction. To contextualize the intention of my question, I'm a bioengineer. I study the origins of life. I think it happened to me the opposite way. So you come from philosophy and then you got interested in science, but I was very deep into the science and I kept being asked very philosophical questions that people just did not understand. They were philosophy. You know, like, you're asking me philosophy. What is life is a philosophical question. Purpose is a philosophical question. So now I'm very into philosophy, and I'm a disciple of Stu Kaufman and Dennis Noble and so on. So I've been reading a lot about your work, and I told Charlie, you've got to invite Alicia because if there is a talk appropriate for this group, is this talk because this group talks about agency, and agency is a philosophical question mostly. Of course, science can interact with that question, can feed it, as it has done for you with the work of Prigogine, which has happened to me the same. So I see my work in the last year, which has been in philosophy mostly, converging with yours. So I'm just so excited. Okay, let me choose one. So I will choose two very briefly, and I think you can just for the first one say yes or no. I found that as you, Aristotle has constrained our thinking, and especially his four categories of causes. It's just it's become so ingrained, and I don't like them. I don't find that four-way categorization useful at all. And I think you are very subtle and you're very rigorous, but I think you kind of want to put away with that four-way, just doing context dependent, context independent. Am I right that you're just completely trying to get away from that four-way
Yeah,
Aristotelian?
because I think that boxes you into certain corners.
Yeah,
that
exactly.
Looking at it from the point of view of constraint, dependent and independent constraint, really
it's much simpler
because you have enabling constraints. If I didn't have the notion of enabling constraints, and enabling what? Enabling a new constraint regime, which to me would be where the novelty is. And so another element is not, it is the novel constraint regime a la Sazmari's major transformations, that sort of thing. Well, all of a sudden now you've got chemistry. All of a sudden you've got biology. It's a whole, I sometimes think of it in terms of topology. It's just that the entire landscape has reconfigured, so the parameters are entirely different. Everything's different that way. So that's why I went to that.
Yeah, same. I think, so it was fascinating to see your work. Like we're thinking so much the same. And then the real big question that I've been dealing with is you talked about a semantic attractor being necessary for some sort of primal agency. Do I understand that correctly?
No, I think what I'm suggesting is that I can understand the formation of a semantic attractor as if it were a dissipative structure, meaning you have individuals, certain constraints, boundary constraints, context independent constraints, then context dependent constraints. And at some point, there is a system-wide dynamic that emerges that happens to have emergent properties. In the case of the neural network of Hinton, Plaut, and Chalice, it just so happened that because it was a neural network, silicon-based, obviously, to read words, what happened was that when they started lesioning the network either above the feedback loop or below the feedback loop. When they lesioned the network above the feedback loop and they presented the network with BED, for example, it would have output that you and I have a grandchild with dyslexia, surface dyslexia, which is they will confuse a 4 for they transpose, or BAD instead of BED, or T. It is not semantic at all. It's just the lettering. But when they lesion the neural network below the feedback loops, and they were presented with, I remember those two examples only, BED, that's what the input to the computer was. The output was COT. How is that possible? And then if the input was BAND, band, the output might be orchestra. The output doesn't look at all like the input. The physical properties are not similar, but it conserved the semantic meaning, of course, because it had zillions of examples in a huge database, right? So I'm not saying that an attractor is necessary, but I think that is one way that the self-organization can happen in the brain. And that's why I was very interested in the work of Chnges, Mante, who have dynamic models where Mante seems to show, it was delayed intervention. And so the macaque monkey had to remember a blue dot that was square, a blue square on the screen moving to the right, or a green round one moving to the left. So it had to keep several variables, and it organized an attractor of red and green, square and round, right and left. And then it integrated those three to produce the right answer. So to me, that's a semantic attractor. That was the answer that Mante, Chnges, and I can't remember the name of the third guy was.
That's cool.
Thank you. I'm going to reach out so we speak again. Thank you so much.
Yes, please reach out to me. Yeah.
Richard?
Hi, Alicia. Hi, everyone. Alicia, I just wanted to say how terrific that was. It was really, really stimulating for me. I really enjoyed it. I don't know if I can formulate a question really, or even really what my thoughts are, but I'll start and I'll see what happens. I was intrigued by something in particular that you said about the constraints, the regularizing or regulating constraints. That was a deep dyslexia moment there, actually, and a surface lexical one. Where are they? So you mentioned the semantic attractors in the deep neural networks, and you also mentioned the notion, Priogene's notion of carrying their history on their backs, and you also mentioned the possibility that the regulating constraints might be in the context, in the environment, I might say. And I just wanted to follow up on that a little bit. So in the neural network, it's clear where they are, right? Because there are deep layers in the neural network, and that was a space of possibilities that was there from the beginning. It was a predefined space, and the details of what values those weights in that part of the network were going to take, they weren't decided in advance, but they were formed through the training, and that's where the parameters of the semantic attractor live. In some biological systems, there's a tendency to having recognized that a system is holding its history, it's doing something path dependent. There's a tendency to say, well, how does it remember that? And go looking inside to see if you can find where it was written, right? You know, if it's not in the DNA, is it in the RNA? Is it in the cytoplasm? Is it in the cytoskeletal structure? It must be in here somewhere. If it's literally carrying its memory on its back, it must be in there. We must be able to find it. We must be able to touch it, right?
Ooh, I don't know if I want to say that. Touch it.
All right. And so I've been thinking recently about the symmetry, potential symmetry, about how a system of components interacting with one another. I've been thinking about waves and interference patterns and shit. But if a system of waves creates an interference pattern with a beat, and the environment starts resonating with that beat,
Correct.
then the environment is holding that constraint, right? So it's like the history of how long that beat has been around for affects how much of the environment gets dragged into synchrony with it. And so if it had only been there for a moment, it would have been there,
Yeah,
but it wouldn't be a thing that sustained or persisted in any way. But if it had been there for a while, then more of the environment gets dragged into it or dragged into synchrony with it. So you would still say that, but there isn't any history in it, right? You like I can look at wherever I look inside there, it's not in here because it's actually out there. It's actually a mirror or reflection of the regulation which is coming from the outside. So I was very intrigued by that remark about the context and the history and this question of where are the memories, right? That where do the higher order structures live, and how can they not be in the system, like they are in the neural network case?
I'm not sure I want to focus on where, and I don't think I want to focus on outside versus inside. One thing complex dynamical systems tell us is that the boundaries of complex systems are really fuzzy. There's not like a nice square boundaries, clear boundaries. If you think of structure, function, and regulation, the regulatory system would be the settings of the functionality. So if you think of homeostasis and the inflammatory system, I am really taken especially by the whole inflammatory system. Where is that? It's not outside our body, but it also is influenced by the context in which we have traversed. So what would be where would be the inflammatory regulatory system would be in the settings and the interconnections of the settings of the endocrine system, of the nervous system, so it's the settings, the timing, the pacing. Look at all those terms. I can't touch pacing and timing. I can't touch the phase of the process. And all of those would be part of what I would consider the overarching constraint regime that holds the organism within the range of viability of survival. So you can take a little inflammation if you happen to, scratch your finger and you've got a wound there. But if you've got systemic what do they call it? Interstitial. That's very so. But where is it? It isn't. The reason it became systemic was because maybe the regulatory system became weakened. How do we know when the regulatory system is becoming weakened? Certainly in ecosystems, it's when you get wild fluctuations. It tells you that the constraint regime isn't able to respond fast enough, that the response isn't effective enough. And so, for example, I would look at the length of the path in a feedback loop, or how well it happens, or is the vesicle through which it happens so bumpy and full of cholesterol plaque or whatever that it gets noisy along the way. So it's that kind of characteristics of the constraint regime that are different from in a forest. I jump around, sorry folks, I can't help it. No individual plant, as I understand it, fixes carbon. It dissipates the carbon as it releases carbon dioxide in the air. But a forest as a whole will fix carbon. Where in the forest is that carbon fixation occurs? It isn't any one location. See, a location to me is a pointillistic notion, whereas a constraint regime, that's why I suggested maybe that's where waveforms, and certainly your term synchrony is one I use all the time. An army of soldiers marching in sync will collapse a bridge. A wave will collapse a bleachers in a stadium, stands in a stadium. But it's not because there are more of them. It's because of the synchronicity. But somebody said, synchrony alone won't do it. Somebody said to me, you need resonance more than synchrony. And I said, all right, so what's the difference between resonance and synchrony? Oh, because synchrony assumes oscillation, but you can have resonance without any oscillation. You still have that kind of holistic dynamic that can then loop back down and control the components. That's what happens with the synchronized pendulum. That it controls the amplitude of each of the components, so they end up swinging in synchrony. So where is the synchrony? Well, it's a distributed phenomenon. It is probably more to do, as I said, with pace, timing, phase, length of feedback loop, noise. If you want to keep going with the information concepts, equivocation, ambiguity, because if these are multiply realizable, it could go in one direction or the other. And so the question is, how much does it control that it's going to go where it's supposed to, rather than try something else? That's how I'd answer it. Look at homeostasis and inflammation, and that's my model. Or carbon fixation in the. See, you get these things. You get
the thing that's difficult for me, right? Because I've been working on transitions in individuality and major evolutionary transitions for a long time, right? And if I put a parameter there that says, this is going to be what the phase of the higher level unit is going to be, well, then I can set it. But I don't want to have to say in advance that there was even a parameter there before I can set it, right? That's the thing that's difficult for me.
It's all self-organized, because the individuation of the person can screw up the homeostasis and the inflammatory system. Too many brownie points will certainly mess up the constraint regime of my endocrine system, correct? Right? And that's the brownies, the external, too much input. But they're always open systems. So you're always exchanging matter, energy, and information with the environment. If it weren't, then you'd get into the problem of, well, then everything's pre-stated and who cares? You're not going to get real novelty. Philosophers make a distinction between identity and individuation. Identity would be, it continues being a lion, throughout, but it becomes individuated as that particular lion, depending on specific perturbations and entanglements with their environment. So you have constraint regimes at every scale, at the scale of the individual, as well as at the scale of the type. See, and for a long time, philosophers said, oh, this business about natural kinds and types, that's just nominalism. That's just a tool we use in our minds to organize ourselves. The answer is no, there are probably scales of constraint regimes, closures of constraint at various levels of organization, and each one involves emergent properties that are different, and each one involves controls and characteristics that are different. So you can't, I don't think I want.
Really stimulating. Thanks, Alicia.
Okay. Thank you. That's a great question. Oops. Henry has his question, Charlie.
Sorry, I was muted and I was carrying on muted. We're pretty close to the hour. So Kate, if you have something quick, we can go ahead and
I have questions.
So I'm so sorry, Henry. Yeah, I saw you had your hand up earlier, and then it got it went down, went up. Do you have something burning and you'd like to ask? Go ahead.
I don't have burning question, but I do have one question there. Right? It depends on who is be burning. Anyway, so I really enjoy your talk because you actually showing the example of when you don't have biological constraint, you change so many potential to biological reality.
Yes.
But I found so many, understanding and share with your idea, but some of them biologists actually cannot, they say, oh, well, yeah, but they're not really appreciated from more deep side. So anyway, just one sentence, but for my background, I'm studying the genome chaos as a new way to reorganize the system. So we think the system as the three components. The first is the information themselves.
Yeah.
And the second is the carrier of the information.
Very nice.
And the third is the ecosystem of the carrier.
And
So when the information build up this one, the higher level always have more strong constraint to lower level. So for example, when people discuss the physical law, chemical law, every time evolution integrated this physical law into biological process is no longer physical law. If you want to say, oh, but it's no longer physical law, it's biological process. To answer the question, like the people mentioned that. So another key idea we actually realized that the biological system, different from physical system, is constantly create new information and preserve such information by the constraint. So in that case, we realize the evolution by and large is a constraint process. It's not for the innovation. The innovation only happen short time and where the situation when this environment ecosystem becomes totally chaos. In that case, the new information will emerge. So I will stop here and I will, ask the opinion.
I'm very taken with the notion of inherently disordered proteins, because I thought, oh boy, this protein fold business is going to mess me up. There's no multiple realizability, one fold per function. But no, apparently they are more recent evolutionarily, and that is inherently disordered proteins that keep their flexibility or disorder, the capacity for multiple. And so I'd be interested to know if if there's an analogy there between chaotic genes and disordered proteins. And I do think that the idea of biology, Moreno and Mosio and these people talk about biology hijacking the constraint, the regimes of the chemistry and the physical. Absolutely. And so, of course, then the next question is, can this be scaled up to the psychosocial? So then the question is, how would those work in the psychosocial realm? Would those be considered more stringent than the biological?
Yes.
Yeah. Well, there you go. See, that's it. Very nice. Thank you.
Awesome.
8.
So guys, we've reached the hour, so I'm sadly gonna have to cut it off, but thank you so much. And
thank you so much, and thank you to Professor Friston and Professor Kaufman for joining. I am honored and humbled and petrified by your presence. See, the question I would have for Carl Friston, and I want to do that for next time, is if you have these new closure of constraints, does that refresh the free energy? Does that create a new gradient, in a sense, refreshes the free energy available?
Kate, did you have a question we could squeeze in quickly?
Yes, please.
Yes. I just wanted to kind of say, first of all, Alicia, I think you're wonderful. You are clearly a soul sister, and I want to follow up with you on lots of points.
Thank you.
But what I want to say to close this down and maybe leave a space for when we hear from Carl next time, because we're very excited about that. But I just want to say you've been making a contrast, what Stu calls between happenings and doings. We have the law, deterministic, and then we have the agentic work. But there's a third space in between that I want to focus on, that the whole computational regime falls within this space. And
nice.
So when we hear from Carl, I want to draw out the fact that all of the computation framework, which is our machine metaphor of the day, to be given it's due, but it's also the place where sentience and feelings and perception enter the stage. And I just want to throw out that we do, in fact, have attractors, semantic
Absolutely.
attractors, and we experience them in binary feelings of pleasure and pain.
Absolutely.
So I think that in order to build upon the active inference story, if we build in the concept of the self, and the self, not self-distinction, that the organism is making in all immune, in all genetic, and all epigenetic, that's something that we're going to maybe make a little progress on. So where is that identity boundary, and how is it drawn?
Very nice.
Definitely has a model, but it has more than that. Has to do with internal and
Correct.
external.
Correct.
So let's talk.
Wonderful. Love it. Love it. Thank you so much.
Beautiful. That
Thanks
was a
for the
great
invitation. I will be happy to share my deck with Charlie, and you can see everything I didn't see.
Please do. Thank
Thank
you.
All right.
you.
Thank you so much. Thank you.
Thank
Bye-bye.
you.
Look forward to seeing you back again.
Bye-bye.
Thank
Yes,
Bye, everyone.
let me know when Carl's is. Thank you.
you. Absolutely. You're on the list. You're
Thank
welcome
you.
anytime.
Thank you. Bye-bye.